Hey guys, this will be video 5 for the how to design and build a custom guitar, sometimes using Stuart McDonald templates, especially on the front end. And I haven't really talked about those much, but I did in the very first video for this series. So if you're not up to speed on that, just go to video 1 and I'll pretty much put you to sleep in that video because I went into really extreme detail about how I transferred from building the 59 Les Paul replica into doing the Flying V's, and then I got a job to do an Explorer, and that was the first Explorer I had ever built, and then realized that was such a fun guitar to build, so here we are. And the cool thing about it, I've made this statement in numerous videos. Once you go down the center line of a guitar and you define either a 25.5-inch scale, like a Super Strat or something like that, or a Tele, or either a 24.75-inch, like a Les Paul replica, or a Junior, the flat top, or an SG, or a Flying V, or the Explorer, it really doesn't matter what's going on the body as far as just strings connecting to a body and making a guitar. I'm not talking about weight and balance, because these are just night and day, the way they feel and the way they play and the way they sound. But you're going to see in this video, I'm going to be spending some time talking about the importance of the neck pitch and getting a guitar that actually feels like this product, rather than it looking like this product but playing like a Strat. And I covered that a little bit in video 1, where I talked about, I think it was video 2, where I mentioned or it might have been I'm sorry, yeah, it was video 2, where I mentioned to the client, when I realized he was a pretty cool guy and going to be real easy to get along with. I wanted to, and I need to back up a little bit. If you're working with a difficult client, that doesn't mean that you shouldn't offer them certain suggestions, but just be careful about getting in under contract with a difficult client. It usually doesn't work out very well, even though you might want it to. You do the best you can, and some people just can't be pleased. So anyway, trying to get myself back on point here. I offered to this guy, hey, I have the ability to turn this thing from a Super Strat into an authentic 58 specs Explorer, replica. I always have to say replica. And I let him know, for the most part, I kind of just did it for cost, because I knew that would make an incredible video series, and it would show you guys how it's almost limitless what you can do. So if you had an old Tele body, you could cut the wings off of it, okay, and glue some blocking in there, glue some wings on it, and turn it into an Explorer. Shave it down to 1.5-inch thick. See what I'm saying? Because if anything, most all the machine work has already been done down the middle, but you'll just have to change, the neck. But the cool thing about working with the Tele or the Strat, these necks are available all day long in either a reproduction fashion, and I'm talking quality companies, Musiccraft, Warmoth, ESP, blah, 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 and just on and on and on. Or obviously, if you get your paws on a true vintage ESP Pacer neck or something like that, the Kramer, and what they're selling for, even right now, is still a really good deal. Even if you paid $600 for a beautiful old vintage neck, call any luthier around town and ask them what they would charge to just build this. And it's not going to be $200. It's not going to be $300. It's going to be, it's going to be up there. Because to me, this is what truly defines the guitar. So anyway, a little bit too general, but it was probably some really good information to kind of recap what it is that I'm doing here and why we ended up, with 4 or 5 videos already. I think this is the 5th video. And I still don't have a guitar yet, so getting very close to it. So going back to video 4, I left off. We had fit the neck, and it was fitting really well. And the cool thing is, I didn't have to do any changes to that at all. other than I just loosened it up a little bit so it's easier to get in and out of the body. But this one's still much tighter than I typically install them. But I'm going to go with it because it's perfectly okay. But if it weren't that tight, don't don't freak out. Don't let that worry you. The other neck was a little bit too loose. If you just pulled the neck up and it just fell out, that's borderline too loose because we're not going to be gluing this in, or I'm not going to be gluing my neck in with tight bond. I like to glue my necks in with epoxy because the whole idea, and I'll digress a little bit, but in general conversation here, my theory is this. I don't want this neck to be easy to take apart down here, so much so that if the guitar takes a gentle fall, that this neck possibly breaks loose down here from where it was glued together. Because maybe it was a little bit of a loose fit and it went in there and it was put together with a water-based glue. Well, it might have been gluing really solid back here, but it was a rubber gasket up here and right there, excuse me, right there, and then it was a fairly good join right here. But then it broke loose because it was a piss poor join and it was glued together with inferior glue. If you have a really exceptional join like we have right here, that is definitely a candidate, an exceptional candidate for just using the tight bond. You will get a phenomenal sounding guitar if you've got joinery like that right there. But my first 5 or 6 guitars, man, it was a nightmare trying to figure out how to get everything aligned and on the correct pitch and clean and in order. And ended up being having more shims than anything. But we don't want that. But if you do end up with a little bit of a sloppy fit, obviously the most important thing is to get that yaw corrected. You know, the roll, the pitch, and the yaw, YAW. And then once you're real confident with that, then let the epoxy fill in any real small voids that you might have struggled with getting under control. And then that epoxy will harden so much so that the tone transfer will be exceptional. But if you allow a lot of water-based glue to puddle in there, it's going to be a rubber gasket. Is it going to be noticeable in sound tone? Well, you won't have anything to compare it to. But I've noticed that in my guitar building, as soon as I put the first string on the guitar and it's laying on this table and I start bringing it to life, it's immediate. I mean, it just is resonant immediately. It's not it's not this, it needs to break in for a day or two and then it'll start sounding better. No, as soon as the strings go on them, they sound phenomenal. And I mean acoustically. I'm talking acoustically. Okay, so I got to spend a lot of time talking about the general gist of what it is we're doing, and the reason that I like the epoxy and I didn't really finish my thought process. If this guitar took a fall, I would prefer it just blow the headstock apart. I would prefer it completely broke in half right there and blew that head off, or either cracked on an angle or something like that, rather than breaking right here or obviously breaking. Sometimes they'll break right here. They'll separate right there. If it was a flat sewn, see, this is quarter sewn. The annular rings are going this way. So I can just about assure you that no matter how hard of a fall this takes, this thing is not going to break in half anywhere in the neck. It could break in half right here, but only because we have no choice but to drill a hole through there for the truss rod. But as you can see with my double adjustable truss rod, I've have an enormous amount of mass that I was able to leave in or either reintroduce so that it's not weak. This is far, far stronger than your typical, I want to say it's like a 5/8 inch slot that they have to drill in order to get the single adjustable truss rod with the nut on top of that. I never do that type neck or that type truss rod. So the first break would be if it fell, it's going to blow the neck apart right here. That's an easy fix for me, even though we may end up having to do some like a stinger, like black paint on the back, or either some sort of veneer, which it's really not that big of a deal. Well, I'm sorry, this guitar would be black, so it wouldn't matter. You just correct the problem, epoxy that part back together, and you'd never even know. But if it, well, just that. So if anything, I'd rather it blow apart up here and let that kind of be the crumple zone in the car. Like if you have a car wreck, that would be like the crumple zone, and it would save your neck to body joinery. And I'm gonna spend about 10 more seconds with this, and then we're gonna move forward. But that would save the guitar and probably even the fretboard and all that jazz, and even by gluing this little fillet in right there, that's going to lend an enormous amount of support to the neck in its entirety, so that if it did take that blow, it's probably not going to come apart in the neck. It's probably going to break at the headstock, which is that crumple zone we're talking about. Okay, so let me see if this is under 10 minutes. 10 minutes and 54 seconds. I'm going to go with it. I'm not going to delete that because I think I covered some really, really good information there, even though I probably rambled for about 2 minutes of that. So if I wasted your time, I apologize, but that's just building the guitar. So let's talk about the next point, and we'll talk about the reason that Les Paul's on the table in a little while. So let's just do a little bit of a flyby. This thing is very close to being finished. I did bump it. That's kind of funny. I have no idea when that happened or how that happened, but it doesn't really matter because it'll get painted up. But that's something that if this were had have been a stained gray guitar, that's what I meant by maybe do that work last, or either keep tape over it so all these corners are extremely well protected so that you're you're not damaging it. Okay. So that's the neck. I'm already down to 1 and 11/16 exactly. Exactly. That's my exact neck profile. Um, I don't know what this is. Let's measure it. See. And keep in mind, this is the 19th fret, and I'm having trouble seeing out of my right eye because I don't know if you've seen any of the past videos. I'm recovering from Bell's palsy. My right side of my face was paralyzed for about a month and a half. And it's a little frustrating because I'm spooked that I might not ever recover 100%. But I have trouble seeing out of my right eye because it stays so watery. That's it's just a little bit over 2 and 3/16 of an inch. So that's awesome. That's the 19th fret location, 2 and 3/16 of an inch width. And even the Fender product with a 25.5 inch scale, they're typically 2 and 3/16 of an inch at the 21st or 22nd fret rough location, according to which guitar you're working with. So we're actually even wider in our trapezoidal path. This being the trapezoidal path, it's more narrow at the nut and it's wider up there. That's obviously a trapezoidal path. So what I'm saying is out here, that's probably going to be right at about 2 1/4, or just ever so slightly. Yeah, it's just a little bit. Oh no, sorry, I'm looking at the wrong thing. Yeah, it's 2 1/4. Okay, so why am I covering that? We got plenty of platform for a Floyd Rose spaced bridge or the Fender spaced bridge, okay, which is wider than the traditional Gibson. Okay, very important that if you're considering putting a Floyd Rose on a short scale guitar with a real narrow fretboard, it's probably not going to work very well for you. Okay, so let me get back on point and get back to the neck, and let's just start back up because I was doing the whole flyby thing and talking about that's 1 11/16 inch nut, and then I'm 2 and 3/16 at the 19th fret. My tenon is per Les Paul specs. It's meaning it stops in the neck pickup cavity. The and if I think the guy's name is Corey, he owns his own guitar building company. He's a super friendly guy, but he sent me a message via eBay once. He's like, I really disagree with your whole tenon idea. You really need more rigidity. It needs to go further up into the body, and blah 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 blah. And he was really cool about it. He was very respectful about it. But it's funny because I have not had time to respond to him, and I kept thinking about, if I start responding, I'll sound like a smartass. But I can assure you, by the time if I sat in the shop with him, he would completely agree with me. And I'm going to grab something off the table if I can find it. Oh, what are the odds that you can't? It may be in the other side of the shop. Anyway, I got a. Let me pause. Okay, so what I'm addressing here is typically in this design, they carried the tenon all the way up to about this point right here, and they cut way up into the body. Now, what it really boils down to is that was basically just the length of a Les Paul tenon, but it started at the 19th fret rather than the 16th fret. What that probably tells me is that back in the 50s, they had two different jigs. They had a jig for cutting a neck, whether it connects the body at the 19th fret or the 16th fret or possibly the 14th fret or something like that. And then they probably have a jig for the tenon. And what they did, they just put the jig for the tenon on that neck, and they ended up having a really long tenon. So in other words, the flying V neck or I think the flying V is that way as well. It is, because I even changed that. So the flying V neck and the Explorer neck, and probably the Modern, was probably a considerable longer stock of wood. Okay, so but where I'm going with this, I didn't see the importance of cutting out into that. And if you want to know the truth, you could actually do it. You could just join it to the body with a dovetail. It doesn't even need to be any longer than that right there, because whatever you cut out, well, you've got to replace it. And as long as you have an exceptional join on the body, what does it matter if it goes all the way back to here, or if it's a through body, design. And I just didn't have time to explain to the guy. Well, I can understand why you're thinking that way, but look how small of amount of tenon is left once it all goes together. This is not a single pickup guitar where we're able to leave that massive tenon, intact. As soon as we put all of that wood in there, well, hell, we cut 70% of it back out. And that, I'll shoot straight with, that's a pretty deep pocket. Usually they're not even that deep. A tenon, a mortise. So, and on top of that, you run an extreme risk. The more wood, I've taken an enormous amount of wood out of that body, and as far as the depth. And if you took that all the way back to here, and then only another 1 3/4 inches, you've cut the guitar in half again, and then you cut the guitar in half again. Well, what's going to start happening is this right here. A board that you started out with that was perfectly S4S and 18 inches wide, was massive and real nice and flat and perfectly true. Well, once you cut that down, once you start cutting it in half, then that board is going to go exactly where it always wanted to go. Okay, and that is basically a automatic arched back guitar. So you see just how much it didn't do it considerably up there, but once you got back here into this area, you can see exactly where that board was wanting to go. And it wasn't just on one side, it's on this side as well. Okay, so what I didn't get to share with Corey is that, hey man, if you cut that guitar in half, you glued it together with Titebond, and you had a piss poor join right there, that I know exactly what would have happened to that guitar right there. It would have it would have actually bowed to our advantage. It would have bowed in, but what would have been a fluke is if it had bowed the other way. Then what would have happened is that body would have bowed open, and the neck joint would have broken loose, and then you're going to get a call back for that guitar, because this guitar went to California, was a fairly high profile sale, and obviously I never shared any of this stuff with him because I didn't worry about it. I knew that the body was fine. It was acclimated to the shop. This was just a quarter sawn wood doing what it wants to do. So, an enormous amount of information there, but therein lies my justification for taking as little material out of the body is as necessary. Yet, when we do our joinery, let's make certain, let me put it together. Let's make certain that we do exceptional work so that once it does either get tight bond glued back together and or in my case epoxy, this is no longer a neck on a body. This is like a through body design. I almost said through hull. I restored a big boat down in South Florida. Always thinking about through hulls and how to bring the seawater in or keep the seawater out. But if you do really good joinery, I don't have to worry about this body either bowing out or bowing in or this neck breaking loose if it falls. Okay. So I got way long winded there, but I think if anything, I probably could just end the video right there and say, hey, that was just body discussion. But let me pause and get organized a little bit and think about how to get back to this neck, and then we'll go from there. So let me pause. Okay, so we're 21 minutes in talking about just body and neck construction, but this is what it takes to build a guitar. And in case Corey's watching, let's really piss him off. So I'm gonna draw a line right here, and I say that jokingly. Again, he was really cool. He was a really nice guy, and I would say his company name, which is a very cool name, but I don't want anybody hating on the guy. So you saw what I did. I just drew I took a pencil and marked in there the area that will be getting cut out. Let me get behind the camera. Okay, so there's really no tenon left up there anyway, and you only have, what was that, maybe 7/16 of an inch max, maybe a half inch right there. That's actually gluing back in. So on that note, some of the first flying V's that I built, I actually just cut the tenon off back here and didn't really worry much about it because in there's a strong possibility that the Norland era Gibson guitar, where they stopped the tenon before it even got to. I'll just kind of. It's not that far. It's pretty far back. And keep in mind it was a Les Paul, so it had a much deeper, body, the full body, the full upper belt. So it had a lot of mass right there, and I understand that. But long story short, they basically stopped the tenon. I can't move it very well because there's so much stuff on the table. They stopped the tenon back there. And as long as you epoxy that together, I can assure you that's not coming apart. You still have these 7 sides that we talked about, 1, 2, 3, 4, 5, 6, and 7. Okay? You glue 7 sides together properly, you got a great joint. Okay? So I don't see the need to pause, but I am going to pause and double check, make certain that I've got the table in order, and then we'll come back, and I need to get a drink of water as well. Okay, so I spent enough time talking about the tenon, and if I do spend any more time talking about it, it'll just be related to how it fits into the heel here. But I think I need to go ahead and just start talking about the router work that I've done. And the shaping and all this was done by hand. And I think I did a flyby on the front. Obviously, we'll do it again very quickly. Still maintaining our marks. The fretboard begins right there. That's the 1st fret location, the 11th fret location, the 12th fret location, and I cut it exactly at the 19th fret location on a 2-degree pitch. That's going to yield roughly a 5/8 inch high string from the top of the guitar to the bottom of the string, which, what is that? It's going to feel like a Gibson product. It's not going to feel like a Strat, which is really low and flat. So that's one of the conversations I had with the client. I clarified, hey, do you want this thing to feel like an SG or an Explorer or a Flying V, or in other words, a Gibson type product, or do you want it to feel like a Strat? And he was like, no, all day long, that product right there. So when he told me that, I knew to maintain that 2-degree pitch. If he had told me that, man, I really love my Strat and I don't want this thing to feel too different from my Strat, even though it's a different product, I would have put this in at 1 degree, and I would have kept that Floyd Rose about 9/16 of an inch max height. Excuse me, I just ate lunch. I apologize, but I would have kept that Floyd Rose really low, like a Strat, you know. But he didn't. So make certain that you know that there are. Just because it might look like an Explorer, that doesn't mean that your client wants it to feel like one. Because if I'm not mistaken, I don't believe he's ever owned an Explorer before. So he's probably doesn't even really know what to expect. I'm hoping he's going to be blown away. So 2 degrees, and it is what it is. This will get shaped a little bit more. That's just the rough route work. And as I had mentioned in the last video, after the last time you saw it, it was just S4S steel, and it was still 2¼ inch wide up here, 2¼ inch wide all the way back. In other words, it was just a square board, rectangular board. But the first thing I did after that was I achieved, the appropriate taper. Now, and I bet you that neck, that's the 19th fret location. These two little slots are going to get cut off because that's the 24th fret location, that's the 23rd fret location, and then you would cut that off right there, and then that would be the 22nd fret location. And what will happen is after that's all said and done, see that line right there? This is really important. There's a line right there, but that represents what would be the 23rd fret, or the end of the fretboard right here. That's the edge of that side of the slot. But what you want to do? Oh wow, perfect that I drew that line. See, that is right. Let me get a pencil. Okay, the camera. See that point right there? And then you see that point right there. That second point represents where it's going to get notched out, but there's going to be a little shelf across there that's roughly a little bit more than 1/8 of an inch. That is where I don't know where they are. That's where the pickup ring will set. Okay. So you want that to be, it's not that big of a deal if you were to cut it completely off, because the pickup ring could float across there. But anytime I've pulled an old guitar apart, there's always been a little shelf right there. Okay. So define the taper, and then once I had the taper, then I was ready to put it in my jig and, clamp it down here, clamp it up here so it doesn't travel. If I could find it. Go ahead and take your CA glue, like a medium, and then glue this. You can see where it got cut off. That was glued on there. It was just a block of wood. And then once the router bit came around, this became a sacrificial board to keep me from chipping any of this off, but also to allow somewhere. I did not use this bit. The bit is still in the router. This is the 7/8 inch cut radius, but the one I used was a 1 inch. But as the bearing comes across here, and if you didn't have something to continue on, you would roll off and you would lose the corner. It would round the whole corner. It would cut the whole corner off, and you'd lose it drastically. So you have to put a board like that. And I used to just put a masking tape there and put masking tape here, and then jet glue them together, or use the CA glue together, and that's fine. As long as that board is just a real clean 90-degree continuation of your heel that you have designed, you'll be okay. But sometimes I make these a little bit wider, especially if I want a real fat profile neck. And then after I get the heel cut with the machine, then I'll come in and just carve everything to exactly what it is that I want. It's an enormous amount of work, but if you're able to use the router bit to achieve, every bit of that was done with the router bit, okay, a 1-inch profile. So don't let anyone convince you that you have to shape your heel by hand. You can do every bit of it with the router bit, and then come in with like a tool. And I'm not going to do it because I don't want to screw it up. You can come in with a tool like this and start blending either blending that way and rounding that over, or blending that way and rounding that over. But I've noticed even in the 50s like the Flying V and the Explorer, they had a bit of a flat right there, and it's really beautiful. It's really cool. But I hope that makes sense. You got to have some sort of sacrificial continuation of the center line so the router bit bearing will have something to roll on or ride along. Okay, otherwise you're going to lose your heel. Up here is a total different story. Your router. I use a much larger base than this because the way my jig is, first off, I've got that bit right there hanging out the bottom. I want a lot more base than that right there. That's really dangerous if you're only riding just, maybe 2 inches up on your support. You're going to run the risk of either getting hurt really bad or either you're going to lose your neck. So the base that I have on my router, it's about that long. It's a big piece of rectangle, and it's 3/8 of an inch thick. It's like just a massive platform. So it keeps it very stable and very safe. So don't use that base if you're reading between the lines and you're beginning to see some sort of jig in the background to allow you to do this. Don't just make assumptions. Make certain that you engineer it really heavy duty. And I'm not going to show it because I don't want the liability. But what's going to happen is once you get up in this area right here, the base, the big rectangular base is going to hit right there, and it's just going to force your bit to stop back here. It's a different story on this side because of the design. The base is allowed to travel. I was almost able to get all the way up there, but don't get too overzealous because you'll catch that corner and you'll take a notch out right there. So no, go ahead and make marks where to stop because you've got to do hand shaping anyway. And what's the big deal if you have to shape off another 1/4 of an inch, to guarantee that you don't F up your headstock, okay? And that's the sign of a good carpenter when you see the original wood up there. But don't be ashamed if your router bit gets up there and tears it up. You have to rebuild it. You know what happens. So if that makes sense, you're routing, this side right here, and then you're coming off. You're flipping the neck over on the jig, and then you've just you're routing that side and coming off. And that little heel block is just I've already covered that. It's just a continuation of that center line, and it's not even a part of the jig. Just think of the jig as being the platform which guarantees that you stay square with the neck. Now, is that what the jig looks like? That's what the base of the jig looks like. But back here, it has another level. Okay, and that allows the router bit, the router base itself, to ride pretty high. So it allows you to go a little bit further than normal. But once you get down here, that platform that you built up on top has to do a horseshoe bend so that your router will have a base to ride on back there. And I say all that to say this. Again, you're not using this base, but after this is all said and done, this is hanging out of the bottom of the router about that far. It's extremely dangerous. And the first few necks that I built that way, I could hardly even, I was so scared that something was going to go wrong that I don't recommend doing that type of stuff. It's not worth it. You can buy your damn necks cheaper than you could risk, getting hurt. But after I realized, oh wow, this jig is safe. It's working really well. It was a brilliant design. I've never seen anybody do it. Again, I wish I could show it, but there's just, I'm 56 years old and I've been working wood since I was 10 or 12 years old. And there's a lot of guys out there that will come on YouTube and they'll get excited and think that they can handle a router. And, when you're working with these big bits, they're running 15, 20,000 RPMs, and it only takes one mess up to ruin your day. So I would rather someone just watch this stuff as entertainment rather than get overzealous about thinking that they can do it and then they're in the garage, tearing up something. So, all right, let me pause again. Okay, the fact that I started talking about that router bit, I didn't clarify why it is that I do that. So I'm going to spend some more time talking about this, and I'm going to slow down a little bit because if you're going to build your own neck, you're going to have to do some sort of router work. The reason I had to design that jig the way I did is because all of the guitars that I build, they're arch top, and some of them are, 3 inches wide at the rim or the side of the body. So I have an enormous length in the heel there that I want to be consistent as it turns that curve and exits the body. If you're building a like a telly or a strat or something like that, that is a considerably easier neck to build. And that's why a guy by the name of Mark had responded. Mark, I appreciate you watching the videos. Keep us posted on your guitar for your son. But I made the statement, I sent him a message back and I said, hey, if anything, when in doubt, just build a telly. And I didn't mean that a telly is a cheap guitar. The telly or the Strat is a brilliant design. And they're so easy to build if you're building your own neck, because now this router bit is in the table, even if it's a big router bit like that. And just imagine this is imagine this is your neck, but it's 1 inches thick. Now all you're doing is going in, and this is the headstock, and this is the end, and we know that you're going to stop at a certain location for where it would have gone up in the body. So let's just grab a number out of the air and say that was 5 or 6 inches. So if you're going to be routing a profile on the back of that neck, well, you've only got to make one cut here and one cut here, not one pass, but one radius on the left and one radius on the right. So you just know where to go in and then run that route. Obviously, you would start that bit way down in the table so that you cut off, just a little bit to start, and then you raise the bit, and then you make another pass, always starting at the exact same location and exiting at the exact same location. So that would probably require that you do, and it's funny, I've never built a telly before a Strat, so I don't really know. You probably have some sort of block uh, similar to how we use the heel. You'd have some sort of little block that once you got to that point, it would force you to come off the guitar. And maybe that block is on a 45-degree angle, and that's probably how they achieve the slight pitch off that's exactly how they would do it. Just thinking about the reasoning, that block would require that the router bit has to go off on an angle, and that would create your real pretty profile, and then you just keep raising this bit so as you go up. And I've failed to make the statement in this video, but I've said it in a lot of past videos. Also, when in doubt, just go buy some poplar from like your local big box and just experiment and build the first neck out of poplar and then turn it into a clock. Okay, and you'll get a feel for things like, how much do you want to pitch that offshoot when you get down to the heel? Imagine we're looking at the neck, the telly neck, and then you're going to stop at a certain point and then offshoot on a particular angle. And I'm just going to grab a number that says probably about 45 degrees would look good. But where you exit off, you need to make certain that there's enough material left at the 16th fret location to receive the plate. Okay, so I say all that to say this. Building a telly or a Strat is a great way to get into guitar building, and even better than that, buy a used one off of eBay or something that's real cheap. It doesn't even have to be a quality one, but just take it apart and just start just assessing how it went together. And as you're disassembling it, you'll see exactly how it was engineered to be assembled. It should make perfect sense. So, but I wanted to cover that a little bit, and I'm going off the cuff here. I had no idea what I was going to. I had no idea I was going to spend this much time talking about some of these things that I've done. But I really feel like this is some really good information and things that I take for granted that I forgot about having to process through 30, 35 years ago. So anyway, when in doubt, build a telly neck, or either just buy one used off eBay for $150 because they're a smoking deal. Okay. So I talked about the neck enough, other than I didn't talk about how to blend some of this in up here. What it boils down to is when that router bit came up to this point right here, it was a fairly hard round over. So just look at any pictures And Keith Williams' 5 Watt World, the Explorer history, a short history or brief history of the 58 Explorer, you'll see all these pictures and you'll just see the defining lines of where the headstock goes. And once you see it turn in the light, you see a real sharp line. Well, just take a mental image of that and transfer it to your guitar. And then just know that don't let this concave, because if this convex is out here, even as it turns, it is still convexing. Okay? Even as it turns, it's still convexing up to a point about right there, and then all of a sudden it flattens out. So it's very much a compound radius turn right in here. And I've made this statement numerous times. As far as building a whole guitar goes, this is the most rewarding part of building a guitar to me. I love shaping and blending this neck in, because this router bit, I had to stop it. It was probably back here, and all of that flat mass was still left in. So every bit of that had to be carved out, blended to the neck profile, which was rounding over. And then, obviously, if you can feel it, then you got a problem. If you can see it, you've got a problem. But just you keep working it to the point to where you are kind of like I said on the other side. You're just kind of doing this stuff right here, and you're just kind of blending it in. But don't sand too much, because you'll end up effing this up back here. Try to go straight to your rasp, and just as I mentioned, keep the pencil marks on it, and then just take off the pencil marks, and you'll see it. I mean, it's very obvious. And on this stuff right here, I've got it in a jig, and I'm working this direction right here, and I'm kind of keeping my hand away, my thumb away from the area up there, and I'm just kind of working it. Sometimes I'm working on the flat side, sometimes I'm working on the radius side. It just varies. But this is an exceptional blade and bit or rasp profile for that cut. A little bitty thing, but don't let it surprise you. And obviously, you want to make certain that you don't want to get in here and create a low spot. So you want this to be a real beautiful transition, and it should never dip down or anything like that. I've often said, always make certain that your first guitar is painted. That way, if you do screw up and carry this trapezoidal line a little bit too far, and you realize, oh crap, man, I should have stopped back here and then blended it all by hand. Well, you could always fill it in with some epoxy and tint it black or tint it white if you wanted, but just um, go from there. So anyway, very to me, a very rewarding part seeing this come together, and then to be able to actually look at it in its entirety as it's turning, and you begin to see the beauty behind. Well, let's put it this way: you have to keep in mind, and it was probably Larry Allers that was the one that designed this, because I heard that he did a lot of the carpentry work for Gibson. So typically, the guys that did all the beautiful work don't ever get credit. And there's some guy that worked for Leo Fender that was really responsible for the precision bass design, which became the Strat. So it's very interesting how usually the guys back there in the shop that are really good with their eyes and the chisels are the ones that came up with these profiles. But we only hear about Les Paul, and Les Paul did not design that guitar. So drive that home. So you have to keep in mind, they came out of the gate having never seen this before, and that is a beautiful, beautiful design, even though I think they might have been 14 degrees and I'm 12 degrees on that headstock pitch. But to me, that blows my mind that someone could just conceive something and then make it happen with the consideration of the pitch of the strings and things like that. Because you have to keep in mind that was a real radical design for the 50s, man. That thing might as well have been from Mars. But we're coming off the nut with a typical jazz pitch right there for the low E. And then, as you progress, that beautiful fan was probably very cool, because the actual Fender design was much, much more flat. Okay, let me make sure I'm not losing anybody here. This is a very steep angle off of the center line of the guitar. The Fender angle from the low E to the high E is very, very much more flat. So this design being so radical on its pitch is what made us want to play Van Halen, because that's the first time we really saw it. So anyway, yeah, very very beautiful design. So the fact that they conceived it on paper and or the conceptual side of it, and then to put it into play, and then actually play the guitar and it be perfectly balanced, it's brilliant. Uh, okay, so probably a little bit too much history there, but it is what it is. I'm not even gonna look at the time because it's probably like 45 minutes or something. I'm just gonna keep talking and try to not get in a hurry, but finish this video so that it will be worthwhile to you guys doing your own projects. Need to make some clarifications. I mentioned that, hey, make certain that you get a good Mighty Mite copy, Shaler S. Jackson design that's steel anchor, steel stud. That's not what's in this guitar. What is in this guitar is authentic Floyd Rose. So it kind of made it sound like that I put cheap $15 knockoffs. These actual are made in Germany, the anchors and the studs, and they obviously are chrome. In other words, they came with the bridge. Okay, and I'm almost certain that James, the client, knows that. But if you guys were watching, that could have been a sleight of hand, and it would have been a little bit confusing. But I'm just saying that if you're building your own guitar and if you're gonna buy anchors, which you're gonna have to buy anchors to press into that body, make certain that they are fine threads. See how that's really fine. Put the anchors in by themselves so you don't jimmy up the stud or the threads here, and then make certain that these are hard steel and always have a little magnet around. And as long as you go that route, these are on eBay, like $15 or so. And super cool guy. And he clarifies in his listing that these are Mighty Mite steel replicas or something like that. So, okay. Here are the knobs. Got them in the other day. That's the knob. We'll only be going with 3, of course, but they come in a set of 4. And when you're buying these, if you're working with CTS pots, which are the Imperial, you're going to have to make certain that I think it's the 24 fine spline. So the metric is very much different from that. And the cool thing is these are only like $15 and they look great. So you don't have to spend a ton of money to get your really good reproduction stuff. But you do have to know what it is that you're buying, because if you don't, see, this is a CTS. Watch it not fit. That'd be funny. Press these in. I haven't tried this yet. Well, I am not going to pause. I'm going to get this right. Usually what you have to do is you're supposed to press on that just a little, not much. And then you can find, yeah, there it is. Okay. So, and what that will do, that will guarantee that the knob is very much perfectly square with the center. It's in line with the potentiometer. Okay, I need some dancing bears to enter about this time, so I can get those off the table. Let me check the time. 48 minutes of some incredibly valuable information. Okay, what else do I want to talk about? String height at the bridge, and I threw that out there at the beginning of the video. In the event I forgot to talk about it, but roughly 5/8 in that area feels like a Gibson. And if you knew that you were wanting to achieve the Gibson feel, basically just kind of take that in. Even though this is an arch top, that distance right there, that's a bamboo skewer. It's just barely over a bamboo skewer is what the bottom of that little thumb wheel should be. That's your conventional ABR1. And then by the time that ABR1 sets atop the little thumb wheel, and it's a little bit more in the bamboo skewer off the body, feels like a 59 Les Paul. And if you didn't have a caliper that you could come in and just go to is that the D string? E-A-D-G. That'd be the G string. Is that right? I hadn't played in a while. I've been keeping up with my course. So you could, if you saw what I did, see, I went to the third string from the bottom because it's the real thin string and it's the closest to the middle. It doesn't matter. You could have measured that one down there, but just measure the middle, go all the way down, and then that's your target height to the top of that string. Okay, so now that you got that, don't touch it. If you like the way that guitar feels that you just measured, whether it's a Strat, whether it's a Tele, or whether it is a Les Paul or a Flying V or an Explorer, uh, beggars can't be choosers. You know, whatever you can get your hand on. If you like what you feel, then just make note of that number. And what is that number? It's 16 and a half, 16 and a half millimeter. So the thickness of the string, just take it down. We'll take it down to 16. Lock that so you don't get a band a screwed up reading. And just put it on your tape. I mean, put it on your scale, and you realize, hey man, I like the way it feels if it's 5/8 of an inch high, and that's why I said from the top of the guitar to the bottom of that string should be about 5/8. If it's within a 16th on either side, you're not really going to feel that difference, okay? But proceed with caution if you do a pick guard, which we will have a pick guard here, or you don't do a pick guard. If you weren't doing a pick guard on this body, in other words, if all this route work was done from the back and it didn't even have a pick guard, it was like a typical, like a Strat without a pick guard, is all I'm saying, then it's going to feel a little different. So just kind of be thinking along those lines that once you might be building this and you might end up with it 9/16 of an inch, and you think, wow, man, that's fairly close. That's not too bad. Well, right up to the point where you get that plastic on there, now you're half of an inch. And guess what you got now? You got a Strat, and you got yourself in trouble because you didn't factor in all these little micro measurements out here. So I'm spending a lot of time in general conversation here, but I just want you to know that there's a heck of a lot going on, a hell of a lot more going on than just the footprint, okay, or a neck that has a headstock that looks like that. What defines a certain manufacturer from another are those critical, are those little critical differences in those dimensions. Okay. Okay. Probably really don't have a whole lot else to talk about because I just don't. I covered a ton of ground there. I do know that. Let's talk. I may have not have done much justice with the flyby because I think I was really all over the map with respect to the intro of this video. But it might have been some crazy information. But sometimes it's really good to just talk about what you're thinking, and it'll flow better. But we've already talked about obviously doing quality joinery, and this is just that. It's perfect. I'm really happy with it. This is a candidate for I could stain this neck. I'm not. I keep saying that, but I could paint this neck and clear coat this neck and leave this body black, and it would be a beautiful joint. Okay, but what I'll be doing is I'll be mixing up some epoxy here shortly, and I'll be tinting it black, and then I will be gluing it in and then letting it dry overnight, and then we'll have a guitar come together very quickly because I don't think there's any more reason to leave the neck off of the body. And I had kind of contemplated doing that all on video, but I've got so many videos where I show how to do that if anybody wanted to see that, and I'll mention it in the next video where you can go. It will be in the last Explorer build, though, probably around video 10 or 12. It'll be where I built the Carina Explorer. I went into some extreme detail in that video, and then even the Flying V's and all the other guitars in the past. I spent a lot of time mixing epoxy on camera and gluing a neck in and showing you how simple it is if you did your machine work properly. Okay. So I think we got a beautiful guitar coming together. And not only is it really attractive, it's perfectly on center and didn't require any weird adjustments like I talked about in the past video. it just stayed perfectly true from day one. So that lets me know that my templates are accurate and I'm accurate with my carpentry, and we're in good shape. And it's always a plus when you get that template right. Then you know in the future if you get a bug to build a guitar, you know that it'll be kind of just put it on cruise control. It'll be easy to do. The only thing I didn't cover is do it right now. I'll take a second. I mentioned make certain that you what I'm doing. I'm dropping a piece of paper behind that all the way down into that bottom right there, and then I want to be assured that that paper does not bind, and it doesn't. So if the paper's not binding, neither will the epoxy. The epoxy will just squeeze out. Okay, so I appreciate you guys checking in. If I missed anything, I'll just cover it in the next video. But for the most part, there was a ton of information there, and I hope you guys got something out of it. I'm just going to stop talking. So I'll see you in the next video. Thanks.